By the way, this is kind of irrelevant, but I think it's worth mentioning. It was Andre's birthday yesterday.
Oh my God.
Yeah, happy
Thank you,
birthday,
Joel.
Emmy.
Thank you, Joel.
Yeah.
Happy birthday, Andre.
Thank you, Spanti.
You got to get a virtual screen of a birthday cake in the background, you know? Congratulations, congratulations. Okay, hey, we only have an hour together, and like I said, not everyone's done the quiz, so I'm not going to go over the quiz. There were a bunch of homework questions that people asked me to solve, and I've done all of those on the homework sheet yesterday. I'm going to open it up here and see if there's any more. I don't think anyone's added any more because the homework really was just to, oh, what's going on here? Homework help math 2E. Somebody erased everything?
Bruh.
That's a different one.
Savage.
Oh, I know why, because this is sorry, wrong math 2E. I'm also with Miss Nice, there's ours, right? That was Miss Nison's class. Okay, so homework help. Let's see how we're doing. Any new ones up there? I don't think so. Okay. One thing I want to mention though is people are posting at the bottom. I guess it's not a big deal, but I won't always see it if you put it at the bottom. If you put it at the top, then I'll know it's one that I have to solve. Looks like someone put one up there. For what problem? Number 7, right?
Yep.
Okay. So if we have time at the end, I can do that one. If not, I'll post a video up and we'll take a look next day. Anything else at the bottom here? I noticed when I was checking your homework, not very many people got number 7. So the other ones, though, I went through, and like some that you had posted, Karim, I made some videos here, so you can take a look at this if you're still having issues.
Yeah.
All right. Oh, number 1 is at the bottom. See what I mean? Someone put a number 1 here at the bottom, and I wouldn't have seen that because it's at the bottom.
Yeah,
Okay. Try and put them at the top, and I'll do those. Like I said, if we have time at the end, we can take a look. If not, I'll post the videos and we can talk a little bit about it tomorrow in our session. Today, what I wanted to do was go over the ambiguous case. So the notes, maybe I should show you that. The notes are, sorry, that's not what I want to show you. The notes are here. So 4.8. Okay, so if you want to take those down now, you can. There's not a lot to the notes. There's 3 examples. Right? And so we'll solve those examples, and then you have homework tonight is just 3 more. Okay, so this 2 BCE on this sheet here. So there's not really a lot of work today. Then tomorrow we'll just go over this ambiguous case, and then for tomorrow there's a bigger problem set. Okay, any questions so far? Okay, so let's take a look at what you guys did. I opened this up over here in another window. Yeah, so if I go back here, let me just move this down a little bit. Oops. So what we were doing, I'm gonna open this one up here, is I asked you, if you didn't get a chance to go through this app, it's worthwhile to play around with it. It started off something like this, and you're given a situation where you have a triangle, ABC. We're told you've got a length of 7, so that's this length here, a 45-degree angle, that's angle B, and they don't tell us the length of side A, which would have been down here. They tell us the length of side B, which is 6 up here. And they said, use the geometry, so you can drag this around. I've made this out so that you can't pull the point to the left or the right. You can just rotate it around a circle that keeps it at 6 units long. And I said, find a triangle that satisfies those requirements. And this was the one that most people came up with. Let me show you that here. Okay, so if we can go to the snapshots. And then I asked you guys to find another triangle. Oh, let me just wait a sec. Maybe that's a little too early for that. Let's take a look again at this guy here. Okay, so Katie found this triangle, and then I said there's another triangle here. Where was the other triangle? How do you find the other one?
You go further back toward the B.
Yeah, if you go further back towards the B, see this is no good because the side length is 6, but if I were to go from here to here, if I were to connect those 2 lines, then that wouldn't be a triangle with a 45-degree angle anymore. I have to keep going. Aha. And there it was there, another triangle. How many people by show of hands saw that one? Just so I can see. Who saw two triangles? Yeah, good. Annie, Margarita? Did you not see the other one? You saw both triangles? Let's take a look. So if I close this off and I go back to the snapshots, I asked you guys to draw the triangles, and Katie drew something like this. Okay, so these are the two triangles. Okay, if you can see, there's a 45-degree angle here. One goes sort of this way, following my line, my arrow, and the other one's a bit smaller. It's down over here. Okay. That was pretty good. So what I asked you guys in the next slide was, back here, was I said, what do you notice about the two angles? If you look at the triangle there, this one has, what do you notice about the two angles? What did you guys notice about these two angles here?
They sum up to 180.
Yeah, 55 and 125 sum up to 180. Okay, so if I go back to the screen here, let me just do that. Everyone said either way, the angles sum up to 180. I had three different responses to that. Yeah, and then I asked you guys, well, how would you get two solutions with the sine rule? You were asked to pick the right version of the sine rule. If you're trying to solve this triangle, you'd notice that the sine of A over A, well, we don't know angle A, and we didn't know side length A. But we knew 45, that's angle B, and we knew side length B was 6. And we didn't know side C, but we knew 7.
So you can get C.
So we could get sine C. So in order to get sine C, you had to solve this equation here. You cross multiply. You guys are pretty good with the sine rule now. And I said, why would there be two solutions to this equation? And to what two angles in the diagram do these solutions correspond? Yeah, Karim, what did you say? There'd be two solutions because?
Because the 180 degree is always added up by two positive angles, right?
Okay. And I see you mentioned you mentioned the Castle.
Yeah, the Castro.
Yeah, how's that important?
Pardon?
Why is that important? Everybody mentioned the Castle. All the four solutions, the four different examples I've chosen here, they all involve the Castro. Look.
The problem has to tell you whether the solution you're looking for is obtuse or acute. So if you tell us, wait. So if you know which angle you're looking for, then you will come up with two solutions, but then you can figure out if it's the 55-degree angle or the 125-degree angle.
Like if they give you the diagram, right?
Yeah, if they give you the diagram and with what you're looking for. Like if you tell me look for C, then I'll find C. If you ask C prime, then I'll find C prime. But you gotta tell me, otherwise I can't find it.
Okay.
Otherwise it's ambiguous. There you go.
There you go. That's an ambiguous. The last slide mentioned to you guys, ambiguous means when there's more than one meaning. Okay. So if we go back to what everybody said here, you all basically said it was something to do with the cast rule, and it's absolutely right. Let's look at this response here. Yeah. If you were to solve this equation here, remember back when we were doing the unit circle, the cast rule would say that the angle, if the sign's positive, could be in the first or the second quadrant. And since it didn't tell you where that angle was, what Alessandro is saying is you have to consider both. And the cast rule would say you could get two different angles here. Okay. And this is why we call this the ambiguous case, because we don't know which one you're looking for. Okay. So we go back, the next question said, okay, do we always get two solutions? Okay, then I give you another example. I said, well, let's look at this triangle here. So 45 degree, and this is going kind of quick because you didn't get a chance to go through the Google, the Desmos activity. I would do so tonight and play around with it, but when we go through the examples in the notes, we'll go a little slower, so hopefully it'll all sink in then. This one, there were two solutions though. Why not?
Because sorry. I'm not gonna speak.
Katie first and then Alessandro. How come we don't get two?
Well, I mean, If you want to have the B be on the angle B, have be 45 on the interior, there
Yeah.
can only be one solution. But if it's angle B on the exterior, then there could be two solutions. But if the 45-degree is on the inside, it has to be 45. Also, because it has opposite.
Well, if I say angle B is 45, then it's got to be the angle
On the
inside the
inside.
triangle, yeah? By
So that's why
45,
there's only one solution.
and there's only one solution. You can see. To try and move this further, it doesn't quite get to the other side. Why? What's with the change in the problem here? What happened to only give us one solution? Lucas?
Because the 8 is it's too long compared to the 7.
Yeah, it's too long.
It doesn't get around before it passes the B.
Okay, good. So sometimes when we're given this situation, like in the previous slide, you could get two solutions, but you don't always get two solutions. If the side length is too long, I think before it was only 6, right? And now we moved to 8. If it's too long, you can't swing it around to get to the other side, okay? So I think that's pretty much what everybody said. No, because AC is longer than AB. No, because angle B would be obtuse, right? So they were thinking, well, if you went to the other side, you'd pick up the 135 degrees, okay? All right, what about the sine rule? So if we were actually solve this with the sine rule, why would we only get one triangle, okay? Says, we got a lot of different, Margarita says, because there's only one triangle that can be made and the angle of C is acute. Margarita, you there?
Yep.
Definitely agree with you, but I was thinking about what would happen if I tried to solve this equation. Did anybody think about that? This is Annie, I think you said because the answer of the sine inverse of the negative solution of the equation is undefined. Did you try it?
Yeah, I did. I put it in the calculator and it says like error.
When you put
or like domain. So I put the whole thing as negative and doesn't, it says domain, something like that.
Well, did you mean like you put a negative number in, or did you do the inverse sign?
The inverse sign of that, the equation.
Okay, we're actually going to do that. Yeah, we're actually going to do that one later today. And actually, it does come up with a solution. Should we check it out now? Let's see if I can have my calculator open. No, I got to wait for it to open up. Well, let's see. Yeah, we'll do that one a little bit later on. It actually has a solution, but there's a problem with it when I try and find the other solution. Oh, did you guys lose the share? You still see my desktop?
Yeah.
Okay, somehow it went to something different though, didn't it? What happened to the Google Classroom here, to the Desmos? Oh my gosh, it's gone away. Is this it? Oh, here we go. Oh, that's not it either. Oh my gosh, it just closed on me. Opened up the calculator. Oh, here, this is it. There we go. Okay, so this one, we'll do this one a little later on today. It actually has a solution, and we'll see what goes wrong. But yeah, there's only one triangle, okay? So not bad, but let's see what else we can find out. Then I said in the last screen, I think it says, what happened in this case? What's wrong with this one? How many triangles could you get now?
2 curves.
0.
None.
Yeah, what's wrong with this one? How come we don't get any triangles?
It's too short.
Yeah, little c can't reach it to the bottom, right? You try and go as close as you can to the line, it never quite makes it. Huh? And then I said, well, what happens if you try using this equation? I think this is the one, Annie, where you get undefined. I think if you try this one,
I got confused. Yeah.
I think you got the one.
Okay.
Yeah? Someone said no because you said no because the answer is greater than 1, and then that's where you get undefined. Yeah. Okay. We're actually going to solve that one again today to see how that goes. Okay. So this is called the ambiguous case, and that's the last slide I asked you guys. I said, why is this called the ambiguous case? Well, some people said because you can get 2 possible triangles. Who is that? I think that was you, Alessandro. Is that right?
Yeah, I guess.
Yeah.
I think so.
Yeah, that's which triangle are you talking about, buddy? The one with the acute angle or the obtuse angle? That's ambiguous. Okay. Ambiguous means more than one meaning, but there's also the idea that you might, because only one given one angle, the other 2 angles vary depending on the sides. That's true. But you might not get any triangles at all. That's another ambiguity. So when we get this situation, okay, and what situation are we looking at? Well, we've got an angle and two sides. Why do I call it SSA anyways? Why not SAS?
Because the angle isn't attached to the sides, or isn't in between the two sides. So you
Yeah,
don't know
if the angle's in between the two sides, how do you solve those triangles when the angle's between the two sides? SAS.
cosine.
Cosine rule. That was the first question on the, yeah, that was the first question on the quiz. But when you have ASS, then it's the different kind of deal. You've got to use the sine rule, and we get what's called the ambiguous case, okay? Sometimes we can get two triangles, sometimes we can get one, sometimes we can get none, okay? So let's take a look at that. I'm gonna share my screen differently right now and go through the notes with you guys. I'm gonna do it with the iPad, okay? So give me a sec here to change devices. And you guys, if you don't have the notes, like I said, there's not a lot to the notes today. You could probably just write this down on a piece of paper and you'd be just as wise. But the notes that we're going to go through are the following. Can you guys all see that perfectly?
Yes.
Yes.
Yeah, you just give me some sign. I don't always see your faces because they take up so much of my computer screen. I have to hide them so I can see what I'm doing. Let's solve this triangle. This is the one we were starting with, okay? Without putting that angle in there, we're going to figure that one out. Okay, so let's cross this one off. If you're given 45, 7, and here it says 5, but I'm going to put this, can you guys change that to 6, just like it was in the app? Okay. How would you solve this triangle? What would the first step be?
Set up sine, the
Okay.
sine ratio.
Okay, so let's set it up. 6 over sine what? Which we'll go with 6.
45.
6 over sine 45 equals, what's the next bit that we can do?
7 over sine C.
7 over sine C, yeah.
Sine C or whatever.
And then what else? Wait.
Bro, my wife.
A over sine. No, yeah, A over
Yeah.
sine.
A over sine. Now, if you notice, we have a completely, I don't know what to call this, like an empty ratio.
Can we just like throw that away?
And we're not going to use that right now. We'll throw it away because we'll use it later on, Lucas. But when we see this, that's a good tip-off that we might have an ambiguous case, okay? But even if you don't see that, you're going to keep going. You're going to solve this little equation here by cross-multiplying, right? So I think we get what? 6 sine C is 7 sine 45, right? What's our next step in solving this thing?
7 sine 45 over 6.
7 sine 45 over 6 is sine C, right? And then continue on. We need our calculator, right? So I'm just going to pull my note here and I'll go back to the notes in one sec. Okay, and I'll take out my calculator. Okay, so what do we have to do on the calculator to figure that bit out there?
Do 7 times sine 45 divided by 6.
Okay, that's like point.
Inverse sine of that number.
Yeah, that's 0.8249 and a bunch of stuff, and then we're going to do the inverse sine of that number. And that gives us (55.6 degrees). Okay, and that's the angle that we see right here. Okay, now where's the other angle that we were talking about before?
A up top.
Oh yeah, well we could solve for angle A. All right. That wasn't really my question though. I was talking about like we had two triangles before. Where do you see the other one? How do you get it?
You can subtract from 180 because it's on.
Yeah, let's just highlight this bit right here. Remember, when you're doing these kind of a question here, if you think about the cast rule, you could have an angle in the first quadrant or in the second quadrant where the sine ratio is positive, right? There's two possibilities there, first quadrant or the second quadrant. So wait, let's just hold off on angle A for a sec, Lucas. Angle C could be 55.6, or what would the other angle be? This here is, that's,
No. Wait.
somebody help us out here. How am I going to find the other angle in the second quadrant?
180 minus
180 minus 55.6.
Right. The other angle is 180 degrees minus 55.6. And that's 124.4.
24.4.
Yeah. Okay, let me just close the calculator off so we can make that portion of our notes a bit bigger there. So remember, there's two angles. There's the 55.6, and then there's this guy over here, which is the 124.4, okay? So when we're solving these sine inverse questions, we always have to consider that there could be two solutions, okay? What would that look like in the graph? I don't get it. Where's this 124.4 going to be?
On the other side.
What do you mean the other side?
On the outside.
Over here.
No, on the outside of C.
You know, oh, yeah, that's true. It's there. You're absolutely right. That's good. I'm with you there. Let me put that in. But there's actually supposed to be another triangle, Lucas, and if I put it there, I don't get the other triangle. Where's that?
Okay.
Where's that other triangle? gonna be?
If you put it like further closer,
Further
where
closer?
it's
Katie,
there ish. Yeah, closer ish. Yeah, there.
So I have to draw another line in here that's 6 units long, and that's going to make an isosceles triangle right inside here. Okay, so we're going to draw that triangle in. Oh, that's not very good. I want to make that better. Okay, let's try and make it. I have to do this with my hand on that. There we go. Okay, so that's also 6 units. Okay, and that means that this 55.6 is also here, but inside here is the 124.4 degree angle. Does that make sense to you guys? So we've got two triangles we have to solve for. The first one, and call it ABC, and then if we call this point like C prime, there's another triangle to solve. Okay, so when we get this, that's why we have to find the two triangles. Let's solve for them, like finding all the other angles that go with it, okay? So let's focus on the big triangle, I'll try and draw that as best as I can. So we need a 45 degree angle, that's A, B, and then C is over here. We have that, this side is 7, this is 6. That's 45, and this is 55.6 degrees. How could we finish off solving for this triangle here? What would the next step be?
You can add up all the other angles and find angle A.
Okay, so angle A would be 180 minus 45 minus 55.6. Okay, I'll make that.
So then we can use a cosine, right, rule to find length of AC.
Well, we can use anything we want at that point because we have all kinds of information. So that gives me 79.4 degrees. So this angle here is 79.4. And well, what else is left, Corinne? What else is left to get?
AC length, side AC, I mean.
AC?
CA.
CA, I
Oh,
got
BC, sorry.
BC, so that's little side A. Yeah, you can.
Yeah, sorry, I thought it was an A.
Yeah, no, this is a B. You can do the cosine rule if you want, but the cosine rule, you got those squares and things. I'm gonna use the sine rule because I think it's a little bit easier, but it's up to you. If I use the sine rule, I've got A over the sine of 79.4 is, I'm gonna use 6 over sine 45, right? Are you okay with that, Corinne, if I just use the sine rule?
Yeah.
I think it's a bit easier, right? Because then you just do A is 6 sine 79.4 over sine 45. So 6 sine 79.4, and I'm going to divide that by the sine of 45. And I get 8.34, or about 8.3 units. And that kind of makes sense if you look at the triangle. Okay? So we've solved one of the triangles, but we're not done because there was another triangle that could happen, right? If I go back to the original picture, we have to solve for the one that's got the obtuse angle of 124.4 in it. Okay? So let's reproduce that down here. What's that going to look like? And I'll do this one in red. Do everything in red so we can distinguish between the two. Okay, so start with a 45-degree angle. And that's a B. And then A is 7 units. And then now the 6 units is coming inside here someplace to C prime. So let's see, can I erase part of that? No, I got to erase the whole thing. All right, I'll erase the whole thing and put it back. Okay, so there's 45 degrees. And we already figured out what this angle here was going to be. Right? What's that angle? What was that one going to be again? It was 180 minus 55.6.
124. 124.4.
124.4?
Mm-hmm.
Okay. All right, how do we finish off the question now? I want to solve this triangle.
Do the same thing, just with the 124.4 instead of 55.6.
Right, good. So we're going to figure out angle A by doing 180 minus 45 minus 124.4. And that gives us 10.6 degrees. Does that make sense, 10.6 degrees?
Yeah,
Why?
No.
No,
because it's a small angle.
it's smaller, right? Yeah? And,
Oh, for that side. Oh.
and when we move that sine AC, when it moved back in here, that angle of 79.4 got squashed down to 10.6 degrees. So that's making pretty good sense. Can I put that in there? That's 10.6. Okay. And then what was the next step? What's left to do? Well, I can just fairly fit it in here. What else is left over to get? I feel like we almost have everything in this triangle, but I'm missing one other thing. What is it?
Side A.
We're missing that little A. And whatever use we did before will work just the same. But instead of doing A over sine of, we had 79.4 before, we're going to put it in the 10.6. We had 79.4, we're going to turn that to sine of 10.6. And that will equal the same as before, 6 over the sine of 45. I'm going to just go this way with it. And so the final answer is that A should be 6 sine 10.6 over the sine of 45 degrees. All right. 6 sine 10.6, whoops, divided by sine 45. I get 1.56 or about 1.6. Yeah, whoops, let's get rid of that guy. Oh my gosh. This calculator's gone crazy. Oh my gosh, go away. What's it doing? Any suggestions from the iPad users of the world out there? Why is it doing that?
Or just swipe up.
It won't go away. I try swiping up. I'm swiping every other way.
No, like to like hold. So, yeah, there you go.
Reset.
Just switch off your iPad.
Shut it off and turn it on. We're doing an example.
Command Shift Q.
You're kidding me.
That's F4, F4. Press F.
F4. There. Just leave it there for a second. Okay, and I'll do that. Okay, so you guys get the answer. Why is 1.6 making sense? Can you explain?
It does.
Let's compare what we had before.
Because angle A is the smallest, so the corresponding side should be the shortest.
Yeah, exactly. When we squish angle A down to 10.6, look at the different triangles. We made this side 8.3 get really small. It got to 1.6. Oh, the calculator went away by itself. Perfect. Okay? And so that's making good sense. So those are the two triangles that we tried to solve for, okay? So tonight for homework, I want you to do 3 little examples of this. Let's try 2 more together. But actually tonight for homework, the question just says to find the angles. You don't have to work out the sides, okay? But tomorrow we'll do more like this example here. Let's look at example. Any questions with that one? Okay, so when we set this thing up, when we see that we've got to solve for an angle using the sine ratio, and it doesn't say acute or obtuse, we have to consider all the possibilities available. Could be 2, could be 1, or could be none. Okay, let's look at these other examples now. If you've taken the notes down, I changed them this morning. Do you mind? Let's put it to the example that we were looking at in the Desmos graph, right? The Desmos graph, the next one that we looked at, we just took that side B, which was 6 up here, was 6 up here, and then we turned it to 8. Okay. Now let's stick with this. It'll be familiar, and then we can try and solve it. Let's see what happens now. So it says solve this triangle, but first draw a diagram. And tonight for homework, some of the questions you have to draw the diagram. What do you do? How do you start drawing the diagram? What do you do first? All this stuff up here at the top. What do you try and draw first? Lucas?
Wait, can I ask her, why did we cancel the data?
Oh, this way Alessandro will actually like solve the one that we just looked at in the Desmos activity. It's the same information. I just changed the numbers so that it corresponds to what we saw with the Desmos thing. Okay?
Yeah.
So I just crossed those out because I wanted to do what we had seen before. Is that okay for you? Okay. So what I was saying is, how do you guys draw this first? What do you guys do first? Lucas?
I would do the angle B first.
Yeah.
And just 45.
That always works really well. So I do that as well. So start with B and draw a 45-degree angle.
And then you make one side a little longer than the other. And, oh wait, no.
Yeah, you're right. One is, so yeah. Side B is, well, side B has got to go across.
On the other side.
Right. It's got to be out here someplace, okay? So I'm going to make this 7. And if I call that C, then that means that the vertex C has got to be down over here opposite the side C. And since this is vertex B, that means that side B has got to be out here opposite to vertex B. But it's bigger than the 7, so that's why it's going to come out sort of like this. Okay? Does that look bigger? That doesn't look that much bigger. Let me try that a bit better.
You could just erase that.
How's that? So there's my 8 units for B. There's C. And then what's the name of the vertex up at the top going to be?
A.
That's right. This is, and the reason I went back to this one, Alessandro, is because we kind of know what this is going to look like, right? This was the second example on the Desmos classroom activity. How many solutions did we get for this one? Just one, right? Just one solution, yeah? And what was wrong? You guys said this side was too long, okay? Well, that's cool when you have an applet to play with, but we don't have an applet to play with. We've just got some trigonometry to work with. Let's see what happens with the trig, right? So how does this one set up? Margarita, if you set up the sine rule, how does it go?
6 over sine of 45 is 7 over sine of C.
8, right? We've changed it to 8. 8 over sine
of 45.
Yeah.
Is 7 over sine of C.
Right, and then you get this missing ratio with nothing in it over here, right? Mm-hmm. A over sine A, okay. And then what's the next step, Andre, in solving for this?
What?
Well, what's the next step? What would you do next?
To find which angle?
Well, we got this bit of the sine rule. I guess what would you do?
Then you do 8 sine C equals 7 sine 45.
Okay, so 8 sine C is 7 sine 45, yeah. And then the next step, Karim, what would you do
And
next?
then you are
Oh, Andre, you got it?
Yeah. Take
No,
you
fine.
divide
Karim could take it.
7 sine 45 by 8.
Okay. And this is, Annie, this is what you're saying didn't work, right?
Mhm.
Let's see. If I'm going to venture with this calculator again. What the heck is all this big? I don't want that. Okay. All right. And let's try. If it's going to behave, we'll use it. And let's see what goes on here. So if we clear out everything, let's do 7 sine 45, dividing that by 8. I get this number here. Ain't it looking good so far? Yeah. And then if I do
And then take,
inverse sine,
yeah.
38.2. It works. It works. This one works so far. So I get 0.6187, and therefore angle C is the inverse sine, and that's about 38.2 degrees. Well, that kind of makes sense. If I look at the diagram, that's looking like a 38.2 degree angle, correct? Yeah? So why is there only one answer? How could I, where's the second answer? Where could I get a second answer? What did we do last time?
You got the other side view. Mine.
Subtract from 180.
So 180 minus, I could do that. Maybe there is a different triangle. Maybe we just weren't so smart to see it. 180.
No, because the other angle,
Oh, wait, 141.8. What's wrong with that one, Catherine?
if you add it, like 45.
Yeah, but look at this. If you take that 141.8 and you add it to 45, we get 186.8 degrees. Can't have that.
So it's not an ambiguous case then.
Right. Well, it's not ambiguous anymore.
Okay.
Depends, yeah. So there's only one triangle, okay? So this one's only got one solution to it. We don't actually get two. And that's because when we tried to figure out the other obtuse angle, it was too obtuse, right? If you add that to 45, it's going to be too big. And that's why you guys were saying, well, you have to swing the arm too far over. Well, if I don't have the app to swing the arm over, I can just kind of see it this way, okay? So we don't consider that. And we just have to figure out the little side A over here. How are we going to get that? Oh, we also need this angle A up here. How do we finish off the problem now that we know there's only one triangle? What's our next step?
You do 45 plus 38.2 and then you minus that. You do 180 minus that.
Okay, that's going to give us angle A. So 180 minus 45 minus 38.2. Andre, that gives us a 96.8 degree angle. And that looks pretty good. That angle up there would be about 96.8 degrees. And what else are we missing? We got one more thing to get.
Little a.
Right, little a. And we just go back into the sine rule. Cosine rule would work, Karim, but this is a little bit faster. So 8 sine 45 is A over sine 96.8. Little cross multiplication, and I think it's 8 sine 96.8 divided by sine 45. I'm looking for a big number here. It should be bigger than the other two, right? Because that's the biggest side, it looks like. 8 sine 96.8, and then divide that by the sine of 45. Well, pretty good. I get 11.2. Make sense? Okay, and we only have one triangle to solve this time. Okay. Any questions with that example before we move on? Okay, how about example 3? So again, cross out the data, okay? Alessandro, I want to work with these ones that we saw. I turned the B to be 4. This was one that had that little arm that was too short. It was dangling across the top, right? Yeah? Try it on your own right now. Set it up on your own. Draw the diagram, and then do the first step. And let's prove using trigonometry that what the solution looks like, okay? I'll give you guys a moment to try that on your own. Okay. Did you guys get a diagram that looks something like mine? I mean, I just made mine into a triangle because let's suppose we didn't know this one didn't work. Yeah, does that look good for you guys? What's your first step in solving for this one? Rin, what did you do for your first step?
Let me see.
BC, yeah, that's little side A, yeah.
Yeah, so I did it like, so you know that B 45 equals B 40, no, 4 divided by sine 45
Yeah.
equals, let's see, 7 over sine C.
Right.
And then you have the A as well.
The A's, you got nothing, right? Good, okay, that's pretty good. What would we do next on this one? Anyone know? Varvara, what would you do, dear?
So it's 4 sine C equal to, like.
Yeah, 4 sine C, yeah.
Is equal to 7 sine 45.
Okay, it's looking pretty good so far. Yeah, then what would you next?
It's sine C is equal to 7 sine 45 over 4. Then you just will.
It looks like maybe this has a solution. Maybe we were wrong because so far everything you said is absolutely right. So
there's no solution.
Why not? Why not? Karen, what happened?
Because, okay, so if you work that out, 7 sine 45 divided by 4.
Can we? Oh, I put 46.
Will give you
Let me catch up. Is it 46?
45, sir.
I know I'm having trouble. There, how's that? Divide by 4. Yeah, I got that. I get a number there.
Okay, you get the answer. But now if you take the inverse sine of that number, it will give you an error.
Why?
Because the sine is greater than 1.
Yeah. Remember we said the sine ratio has always got to be less than 1. Why is it always got to be less than 1? This is greater than 1. So the sine inverse of 1.237 is an error. Do you remember, Katie, why it has to be less than 1?
Because
Is it the thingy?
if you look at like
Lucas is saying the thingy, the unit circle, right, Lucas?
Yeah.
Katie, what were you saying, dear?
I was gonna say because if you have it as a 90-degree triangle, the leg can't be longer than the hypotenuse.
Okay, there. Or even if you put it in the unit circle, you can see the y has always got to be smaller than the r, right? And it doesn't matter where that point ended up. The y is always smaller than the r. So that means that the sine has always got to be less than 1. Once we get the sine is greater than 1, there's no solution. There's no such triangle. And that's an easy one to solve. You're done. There's nothing to do. Just have to show that there's no other triangle and you're finished, okay? The important thing is that you show that there's no triangle by doing the trigonometry, okay? Don't just draw the picture and go, oh, if you ask me, there's no triangle. It looks that there's no triangle by that. And you have to actually do the trigonometry to show that. Okay? So ambiguous case, let me just back up a bit. All of these share the same pieces of information. You're given two angles and one angle and two sides, but the angle is not contained. If it were contained, it'd be the cosine rule. So you set it up with the sine rule, and then you have to investigate, can I do two solutions? Because if I get one angle, I could always get the obtuse angle. Is the obtuse angle too big, like in this example? Therefore, I only have one triangle. Or is there no solution? Because when I set it up, I get a number bigger than 1 for a sine ratio. Yeah, does that make sense to you guys? Do you have any questions?
No.
Okay, well, that's all I have for you today. What I'd like you to do is, let me just, can I break off on the Google Classroom here? Change the share. We have it here, I think. Well, it's actually better for us to see it. So what I'd like you guys to do for homework is on Google Classroom. I'm going to open it up so we take a look first. Not a lot. There's only 3 questions there, okay? It's quality and not quantity tonight because it's really about understanding a little bit of how this ambiguous case works. Okay, so let me just get our Google Classroom open here. So for homework, I just put on, where's the classwork? Classwork. Can you guys see my desktop? Is that happening?
Yep.
Yeah, okay. So the ambiguous case, not the one for tomorrow, the one for today, is only got 3 questions, 2, B, C, and E. So if you look at this worksheet, we're going to use it again tomorrow. You just have to do question number 2. It says, determine the number of possible triangles that could be drawn with the given measures. Okay, then find the measures of the other angles, and only the angles. You don't have to find the other sides. Round to the nearest 1/10 of a degree if necessary. Okay. All right. Any questions with that for homework, guys? No?
No.
Okay, so if you've got some work to catch up on, or you need to email it to me or something like that, please do. And you can work on this for tomorrow. And tomorrow we'll take these ones up. We'll take up any other homework problems you have, and then we'll just work on some more questions on that worksheet tomorrow. Okay, so it should be a shorter meeting on Zoom tomorrow, and you can ask questions about how the homework worked out. Yeah.
Okay.
Right, sir. Thank you.
Bye, sir.
Thank you.
Yeah. How are you guys making out with the other classes? Good.
Yeah.
Yeah.
Yeah, you keep up with the work.
Yeah, definitely.
Who's there? Dylan, you're not by yourself. We had a guest in the class today.
Yeah, this is my best friend Mia. She's staying in my house. She's been staying here for the past like week.
Does she know trigonometry?
I'm sorry, what?
Does she know how to do trigonometry?
Do you know how to do trigonometry? No, she doesn't. She's dumb.
Okay, all right. We'll see you guys tomorrow. Unless you have any questions for me, I'll hang on the line for a little bit. If not, I'll see you guys next day.
Bye.
Bye, sir.
Sure.
Yeah. Bye-bye.
Bye, sir.
Okay, Andre, good. Bye, Margarita.
Bye.
Ciao, ciao.